Hello everyone. Today I would like to focus on installation, operation and basic measurement principles of Lenovo product line, from miniRaman spectrometer to RG Raman spectrometer with 785 laser and 532 nanometers laser, as well as our microscopy platform called RG Raman microscope. This platform can operate both with miniRaman and RG Raman spectrometers inserted inside. Let's start step by step. For example, miniRaman spectrometer. This is a basic tool, the device. If you order it, it will come together with USB-C cable, a set of accessories depending on your order, and basically that's it. It's very simple in operation. How do we start the operation? First, you should go on Lenovo website, lenovo.com, click on software, and here you will see multiple options. Please select the latest version of MiraSpec software, click download, and if you are the new user, a website will ask you to register. If you register, our moderators will approve you, and then you will be able to download software and see many other contents on our website from your account. When software is downloaded, it will look like that with multiple folders. Please run MiraSpec. Double click and wait for a while. Now you can see that interface appeared, which means you can connect miniRaman by USB-C cable, for example. miniRaman can operate wireless through Bluetooth connected to PC or Android tablet. However, today we will focus on connections through wire to Windows operational system. In order to start proper operation, please go in Help, Set Configuration, and select Configuration folder. Here you will see miniRaman microscope, miniRaman spectrometer, RG Raman microscope, RG Raman spectrometer folders. Since this is miniRaman spectrometer, open the proper folder. This one is a standard dual with 660 laser and 785 laser. And that's why I select the appropriate license. So software will restart. Let's extend it and press connect. It could take a while for connection, up to 1 minute. Now you can see COM19 and the serial number of the miniRaman spectrometer 126. You can see the same serial number here, 126. Which means it is ready for operation. In order to check that everything works properly, you can turn on lasers. Let's say the 785 laser, press turn on button, and I suggest miniRaman spectrometer has reference spectrum. Please activate this option to see it. Right click, fit to window, and you will see the spectrum of the reference channel, and obviously there is nothing in the main channel. In order to see both lasers with both windows, you can drag and move it. On the other screen there will be a spectrum of polystyrene as well when I turned on 660 nanometer laser. You see this laser is on and I can see the spectrum. In order to get a spectrum of interest, you can insert one of the multiple probes, point it to the sample, and here you can see CH spectrum of toluene. If I'm out of focus, there is no spectrum. If I'm closer to the focus, there is a spectrum. The same story for 785 nanometers laser. By the way, this is a spectrum of HEP10. Yes. And you can see how it looks. Also, you may note that there is a contribution from outside environment that can be compensated in multiple ways by protecting the environment with dark cover or special set of accessories, but let's focus on something else today. Of course, I have some other samples. Toluene, yes, it's very strong Raman. Scatter, and I connect another laser. There is a CH region, high frequency region from 660 nanometer laser of the toluene as well here. That's how you connect, how you obtain spectra, and we will make a separate video for detailed software operation principles. Right now, I would like to disconnect miniRaman spectrometer, press disconnect button, and I should wait until it's blinking blue, not constantly shine as blue. It is blinking and I can disconnect. Let's try RG Raman spectrometer, 785 nanometers excitation as well. Okay. For that purpose, I should also connect USB-C and power. Similar to miniRaman, we wait until it's blinking blue. In software, I could already set configuration for RG Raman spectrometer 785. Software will restart. While we're waiting for software reload, I can insert the Raman probe here. It is middle distance probe, 15 millimeters. Yes. Like that. And I press connect. And again, we wait for some time for connection being ready. RG Raman spectrometer does not have a reference channel, so there will be only one active spectrum. It is connected. Let's expand the software, turn on the laser. We turn on the laser, and spectrum of toluene has appeared, which means everything is connected properly. We can maximize the throughput. Device is truly confocal, so that's where I focus on the surface of the glass vial. A little bit deeper, there is a spectrum of toluene. How about some other sample, HEP10 for example? Yes, the same story. HEP10, methanol, so the spectrum of methanol. We can increase exposure time to see it better. Yes. Then diethyl ether. Here we are. Here we can also see that device has been properly connected and operates well. I click disconnect and unplug USB and power. When it's blinking blue, it is blinking blue, so I can do that. The same situation would be for RG spectrometer with 532 nanometers laser. Let's do this procedure once again for this system as well. Power, USB cable. Also the Raman probe. We insert it here and we change configuration file. Set configuration, configurations, RG Raman spectrometer 532. Software has reloaded. We press connect. Now we can extend it. I can go in spectroscopy, plots, Raman 532 and drag this window here. We still wait for connection. When this field connect disconnect is not active, it means that we still need to wait. Ready. Let's turn on the laser. Maximum laser power in this system was around, I guess, 180 milliwatts or so. And again, we wait for laser power stabilization. We can also plot window of the system in nanometers range as an option. So we switch from nanometers to inverse centimeters. Now let's measure the sample. This would be toluene, and here is the spectrum of toluene. We can also focus on a glass and get deeper inside the material. Diethyl ester. Methanol, heptane, sorry. Spectrum of heptane. Spectrum of methanol. Exposure time is 200 milliseconds here. And you can see an excellent spectrum quality for such a short exposure time. So if I focused on glass, you can see the spectrum of used silica plus a little bit of methanol. I get inside and you see spectrum of methanol. Good. I turn off the laser, press disconnect, and we wait until it's blinking blue, not constantly shining blue. Now it is ready. Good. As a next step, we can open the cover in RG microscope and insert one of the devices. This procedure, we start with connecting adapter to the spectrometer. This is an adapter plate and screws. So we locate it here. We select the key and connect, mount the adapter. Good. Second step, there is a directivity tool here that also needs to be inserted, as I show. This would be the final step. Now we come closer to the microscope, and here we have as well USB-C connection and power connection. Here is the wire. When disconnected, we are ready to connect the outside power to the microscope. For that purpose, we have two circuits, power connection, and a second part would be USB connection here. Done. Now you could see that RG spectrometer has been loaded, and we start inserting it inside the microscopy platform using this directivity tool. Then we use a screwdriver with two screws to connect it. One screw and the second one. No alignment here is needed. Then also two more screws for the laser cooling air ventilation here and here. This is it. The final step would be cover, which we can lock with additional screws on each corner. Now, as before, we go in software set configuration and select the proper configuration. So that was RG spectrometer. We go RG Raman microscope and select an option RG microscope 532 RG spectrometer inside. Software will reload. Yes, and we press connect. Let's extend it and wait for connection. While we're waiting for that, we can already make a window in an area where we like for Raman spectra visualization. For example, here we can turn on LED here. Yes. And now finally everything is connected. We can see it's COM25, the serial number of the RG spectrometer, stages are ready for movement. You can check that. For example, you move the stage and you see that the visible image reacting on that. If not, press home and stages will calibrate and then find visible image again in the proper focus. Axial movement also works. Here as a sample we have polystyrene bits. Let's turn on the laser. However, it's quite powerful laser for polystyrene bits at high magnification. They have diameter 3 microns. So I would say probably around 20 milliwatts would be good enough. We press on and wait until we see actually the laser dot here on a sample. So exposure time is 200 milliseconds. Probably you already see how laser dot appear. Here we are. We also can right-click Fit to Window to see the live Raman spectrum. Those are the polystyrene beads on calcite, on calcium fluoride, and we can see the peak of calcium fluoride at 300 something inverse centimeters. Here it is. So let's move to the polystyrene beads. Slowly, we can see two polystyrene beads here. So let's come and focus on them. And you can see a spectrum of polystyrene has appeared. We can add one more 0, 2 seconds to see it better. Yes, and you can see it way better, and it's burned, unfortunately. However, we can even see how it is burned. Yes, that's the power of Raman spectroscopy combined with visible image live observation. So, for example, I can crop, select this area, and we can in real time see how laser interact with the sample. Let's say we reduce the exposure time to see the live changes with the spectrum, and we move over the sample, yes, like that. Let's observe some new area here. On this polystyrene bead, for example. And of course, if I will increase the power, 50 milliwatts, we should burn the bead. Yes, it was burned. And now instead of polystyrene, we should probably see two peaks of carbon somewhere here. But there is still some polystyrene as well. Anyway, today our goal is to understand the operation principles, connectivity of multiple modules to the Raman spectrometer. And I think this goal we almost fulfilled. Nevertheless, I would like to show how other spectrometers would work. The benefit is that you can change spectrometers without any alignment, and they work perfectly. Let's prove that. For example, I would remove the crop image so we see it as a full scale, and you can see the laser dot was around here in the bottom corner. I can place the cross line here so we remember where it is. Let's turn off the laser, press disconnect, and remove the spectrometer, change it for another one. In order to change the spectrometer, again we remove two connection screws. For the ventilation first, and then second for spectrometer connection. Good. Very nice. When spectrometer is blinking blue, it is ready to be disconnected. And it is blinking blue now. We remove power, we remove USB. Let's place it here. And now we will insert another spectrometer. For that purpose, I remove from the first one the directivity tool. That will help us to place a new spectrometer without any alignment additional needed. Now we connect USB-C, power, and place it inside. Here we should be careful with the wires, so they do not block. The spectrometer pass. Again, 2 screws. Screwdriver. It does not require tight fixation, so no extra pressure is recommended when you do this procedure. Cover. Good. Now, as before, we should set the proper configuration. We go into the configuration settings and we select 785 RG microscope file. Software will reload with the proper settings now. And here we are. Let's press connect and wait. You can see that we have moved from original position during our manipulations. I remember we had approximately this area. But what is important for us that our laser point previously was where we have this cross line. And right now, let's see where it will be with the new spectroscopy module. So this time it will be 785 spectrometer instead of 532. And it's ready. Now I can turn on the laser power. And let's wait for the laser to stabilize. Meanwhile, we can open the window in spectroscopy plots Raman for 785 nanometers, and here it is. And I also can see that, let's say, we don't have extended spectral range. So I opened another window, which is here, spectroscopy plots, spectroscopy, wave number acquisition parameters, wave number range, and I extended it to 50 because this is research grade spectrometer and it can operate from 50. And now we can see the peak of calcium fluoride here, because it is a substrate of calcium fluoride. Okay, where is our laser? In order to see the laser spot well, we may need decrease the power, and here it is. Probably you can see here is a spot. So yes, it is located in slight different position here in comparison to the 532 laser, but it does not change anything, simply because spectrometers in combination with microscopy module designed in a way that no matter of the fluctuation of the laser spot position on the visible image, it is still perfect sensitivity and throughput of Raman spectra. So in order to understand where you spot with the new model, you just change the cross-line position in the new point, and everything will be good. To prove that, we can focus on polystyrene, and now you can see the spectrum of polystyrene. We can try to find a better signal. Here it is. I can add one more zero to the exposure time, and instead of 200 milliseconds we will get 2 seconds, and you can see a spectrum of polystyrene bead. The good thing here that when I changed one spectrometer with green laser to another spectrometer with near-infrared 785 laser, we worked hard here to compensate on chromatic aberrations, so you still have a match. The smallest laser spot size fits with the best image quality. There are minimized chromatic aberrations, so the sharpest image in a visible light would still correspond to best focusing of your laser beam. And if I move slightly out from the sample, you would see no signal of polystyrene bead, but the spectrum of calcium fluoride. For our test, this is enough with this system. We don't have a purpose today to focus on any software features, operation, and Raman mapping. So I turn off the laser, I press disconnect, and we will remove RG spectrometer and change it for another one. As usual, we unscrew the airflow system for the laser, effective cooling from RG spectrometer. With another screwdriver we remove RG Raman module. It is blinking blue, which means it is ready to be disconnected, and I disconnect it. So finally, let's try to operate with miniRaman spectrometer in microscopy platform. What should we do for that? There is a special adapter for connection. Nevertheless, we still use the same directivity tool, so I unscrew it from RG spectrometer and place for the adapter into the miniRaman spectrometer this way. Yes, so we connect it with the entrance pupil of the miniRaman, lock it, and we have 4 additional screws to fix it to the adapter. Again, we do not recommend extra pressure here, so just like that. Good. Now it's ready for insertion. And in case of miniRaman, we need only USB-C, no extra power required in this case, and I insert it. Two screws. You can use the same one to fix. You can hear the sound that it has been already connected to the laptop. Good. Again, no alignment is needed. As usual, we go in Help, Set Configuration, and select proper configuration, RG Raman microscope, miniRaman dual with 660 laser, 785 and 660. And we reconnect it. Let's extend, press connect. Time to time you can see that there is no camera has been recognized. Then we go visible microscopy, file, start camera, and image will appear. However, we still wait for connection, so this field connect, disconnect need to be active. We do not recommend to press any other options until it is fully connected. Now it's good. COM25 and serial number of miniRaman spectrometer is here. So we can go again in spectroscopy plots, let's say 785 nanometer laser, and place it here. We can also open another plot for 660 nanometer laser and place it here. So let's turn on the laser. Now we probably would like to find the laser spot on the sample, and for that we probably should focus a bit. And you can see here is the laser spot. So let's move towards the sample and we locate it on polystyrene. And you can see a spectrum of polystyrene on the screen as well with 785 laser with miniRaman. Let's turn off this laser and turn on another laser, 660 nanometers. Switch on it here. And where it is? I guess here is the spot. Here. So yes, it is okay in miniRaman that spots for two lasers do not match perfectly. And when we focused on polystyrene bin, we also can see a Raman spectrum of polystyrene in high frequency range from 660 laser. Good. I turn off the laser, press disconnect, and I believe now we have way better understanding how to operate with RG Raman microscope in combination with multiple light novel spectrometers like RG Raman and miniRaman spectrometers. Thanks a lot for your attention.